Hi everybody, thanks for coming here and during this talk. I know Jordi's in the other room, so I'm kind of competing towards for your time here right now towards a guy that is a little bit more famous than I am. So thank you for coming here. Who am I? I'm Frank. I'll be complaining about file systems today. So first you get like an overview of what I'm going to talk about today is basically this. What is a file system abstraction? A file system abstraction in SCORE is a way to encapsulate file systems that allows the storage engine to become an implementation detail. I'm going to explain this further on in the talk, so if you don't get that fully, that's all right. So there are several topics that I'm going to address in this talk. First, I'm going to tell you what file systems are. Then I'm going to tell you how to use file systems. Then we're going to move from local file systems to remote. And then we're going to use a file system abstraction. So first off, what is a file system? The first couple of slides in this presentation are really basic things. Like most of the things that I'm going to talk about, you probably already know to some degree, but it's good to level the playing field so we all are on the same page and we know exactly what we're talking about. So we're going to create some context for you. So what is a file system? Well, basically, in its most purest form, it's just structure and logic. So if you have a disk, which we commonly refer to as file systems, then what's on that disk is just a blob of data. And if we look at that data, we either have to read it all in one go, and we don't really have a nice way of working with it. But, so you need a way to wrap your head around what's on that disk. So we use structure in the form of folders and files, and we use logic for it as well. So you have a way to address certain parts of the file system independently, most commonly referred to as files and directories. So if you look at what consists in a file system, it's basically these three things, and they're kind of correlated as well. Like, of course, we have files. We're talking about file systems here, but we also have directories and we have metadata. So, like metadata is like modified time, or what's the file size, or what's the MIME type of the file. So if we look at what's common in these metadata sections, we have a couple that are applicable for both directories and for files, and that's things like locations and paths. Locations and paths, it's not like your file system is this big pile of files stacked on each other, but we use an abstraction, which is the file system, to address certain areas, and we use concepts like directories and like files and file names for that to be able to point at what we want to address. Then we've got file timestamps like modified time or access time, whatever kind of file timestamps you get. And they tell you certain things about the files, like when was it created, when was it last updated. These are things that we like to know and we like to anticipate on. And then you've got things like permission and ownership, like if I have a file somewhere, who can use it? Is it publicly available or is it just for me? You want to be in control of that. And then you've got file-specific things. So I told this before, like MIME type, file size, but also the contents. Like in a way, contents is only a part of a file, so it's actually at the same level as the rest of the metadata really is. And because we now load, paths and stuff like that, you can also derive information from that. So in PHP, we have the function pathinfo. Probably everybody here has used it to some degree, like get an extension of a file name so you know how to handle something. But it gives a wider range of new derived information. So things like file name, base name, extension, the dir name, so in what directory is it, and the MIME type. Well, it doesn't supply the MIME type, but that's another thing that you can get. So if we look at a file system structure, it basically boils down to these two setups. On one end, we have a nested file system, and on the other end, it's linear. Who here has used S3? Well, if you've used S3, you know about linear file systems, because that is a linear file system. Every path is just fully that. There are no linear directories. So nested file systems is what we're used to. Like if you are on Linux and you open your file browser, or you're on Mac and you open Finder, or you're on Windows and you use whatever Windows people use to watch files. I don't know, don't use it. So that's what we're used to. Like we create encapsulations of files so we can look at it and reason about it in a more easy way. We don't have to think about all the files in the context. So we go into a directory, we see files and we see more directory, but the context is limited. That allows us to be more precise about what we're inspecting. We don't get everything that's on there. So that helps us. But then on the other end, we have linear file systems, and they're more like a key value store. So it's like you've got a file system that is based on something like Redis or Memcache, something like that. And they do require a different approach because they're not structured in the same way as nested file systems are. They do have files, but they actually don't have directories. Everything is full path, so directories don't exist. So concluding to that, you can pretty much say that directories are myth. They don't really exist. So now that we know what file systems are, we can use them. We can use file systems and we can perform various operations on them, like things like write, read, copy files, delete files, and all sorts of operations. But if we do this in PHP, it sometimes is kind of a pain. I'm going to complain a lot about how PHP handles this internally, while some of the things are just great, like using file get contents. It's super easy if you compare that to our language, is a big win, but it also has its downsides. So if we look at some vanilla PHP, these are basically the operations that you can perform on them. So we write, we read, we delete a file, we inspect a file, like we get the modified time, or we get the MIME type, and we first had an easy way of doing that, but that's not deprecated. So now we have to use an object for it, so a finfo class instantiated with a file info MIME type flag, and we need to locate a file or whatever, and then we get the MIME type back. So here it already starts to become a little more complicated than just random functions, and because the MIME content type function is deprecated, now on one end we have functions that we call, but in the other context where we use the finfo classes, we're using objects. So it becomes kind of a weird mix to mingle that together. So things become drastically more complex when we're talking about listing files. If you look at listing files, like, do I use glob, do I use scandir? Readdir is a whole different thing because it needs like a directory pointer. Or we have some SBL classes that can help us out, but they become quite complex if you look at them. Like the last one, you need to have a recursive iterator over a recursive directory iterator. Like you don't want to have to think about that every single time that you want to list files. But not only that, which one do I use? Like, why would I use one over the other? It's not really clear. They're just different methods of doing the same thing. So you're forced to make that decision every single time. And sometimes you want to quit, so you just do a glob and be done with it. And the other time you want more complex stuff and you use the directory iterators. But it's up to you every time to make that decision. So then when you use big files, like here, are there any people here in this room who use file system stuff for big files, like more than 5 gigabytes? I see two. Well, if you do something like file get contents, you basically load that entire file into a string. So that means everything is in memory. So if you have a 5 GB file, you need at least 5 GB of RAM for your process, and chances are your application doesn't have that, because most of the times it doesn't need it. So loading a file that big can actually break your application. But we have different tools in PHP that help you with bigger files, and they're stream-oriented. So basically, you open a file stream, which is like a pointer thing, and then you can use that handle to perform operations on it, but you only get bite-sized chunks of data, so you only work with a small bit of data at a time, so your memory usage stays low. So if you have memory problems, streams are the way to go. But as you can see here, if we, this is basically opening a source and then writing to a destination, so it's something like copy. So if you then look at, like, why would you write all that code when you can just use copy, right? Well, I thought about the same thing, but then you encounter new problems because the source and the destination, they both need to be locally. So you can't have the source be on, say, Amazon S3 and the destination be local or whatever for uploading and downloading, and you switch it around. But they must be locally, so we can't use that. So we're forced to use the streaming way. So this is kind of annoying. Like, we have so many different options. Like, why do I use something in one situation and in the other situation, and I have to use something entirely different? Sometimes I know why, sometimes I don't. And these things make development more complicated. So this was the complaining part. Oh no, there's more complaining coming actually in the next topic. But this is just vanilla PHP and what's kind of wrong with that, or what the pain points are when you're working on it. So nowadays, when we're creating apps, I saw numerous people here use S3. Probably somebody here also uses Dropbox for something, or uses the FTP functions in order to talk to a remote server. And there are various reasons to do that. Like, these are the positive things. I'm going to go back to the complaining a little bit later. Why do we want to do this? We want to scale our applications because we need more servers aligned next to each other. Well, if you guys probably already know how that scaling stuff works, so if not, there are plenty of other talks that can explain that very well. So if you want to scale, you want stateless apps. If you have apps that run on multiple machines and they all just talk in a local file system, they become unaware of each other, and if you're load balancing and you write to one local file and then you get pointed to a different server, all of a sudden that file is no longer there. So that won't work. So we need to centralize that. So one way of doing that is creating a remote file system. So that's what we're kind of forced to use. Another thing is, like, if files are the meat of your application, like a lot of people handle just HTTP requests and respond to that and talk to databases, and then that's the meat of your application. But if you are in the industry where you're handling files, say you have some sort of CDN application or a video distribution application, files are important to you, so you must focus on that. And you must be able to share it across the instances that run it. And also, a different thing is, you want to enable nicer ways of interacting with your application. In one example, I told about the video stuff before. I know a company that built a video application, and they had some trouble with uploading stuff because of the slow feedback loop in PHP. Like, if you upload it through an HTML form, it tends to, it doesn't give any feedback, and you can use AJAX requests for that. But if you're using large files, chances are that's going to break as well, and then you get connections that drop, and that's super annoying. And there's no way to fix that in PHP. But what we can do is utilize what's around us, something like Dropbox. So what they did in their application is they opened up a folder for people to upload on Dropbox. So that's just handled for them, and the only thing that they have to do is have a background job that pulls in the videos from Dropbox. So they do have every bit of the feedback, but that's given by Dropbox. You don't even need to deal with that. And they can just focus on handling the files. So that's a huge bonus. But there are also some consequences to this. For starters, we can't use the PHP built-in functions anymore. We have to start using APIs. It's not bad, but still some extra load. And we have to depend on third-party code. And that has some side effects as well. I'll compare a couple of ways of doing stuff with various remote file systems. Like, if we write to S3, we have to somehow get an array of things, and we need to think about what we put in that array. Like, we don't have like a method with parameters that are auto completed by our IDE, so we have to somehow validate that array for ourselves. And here you see we've got the options array, and we call the put object method on the AWS client, and in Dropbox it's something entirely different. So we do a file, upload file from string, and then we have totally different parameters. Then if we look at Rackspace, it's upload object, but then also different parameters. WebDAV, you call a request method if you want to upload, so that's a bit iffy maybe, because you're not requesting something, you're putting something there. And then when you use FTP, this is where it gets really interesting, because if I want to write a string and I want to write to an FTP server, we can't use strings anymore, because the FTP built-in functions only support strings. So first we have to create a temporary string, we have to write the data to the temporary string, then we have to pass the string, then close the string again. So this is quite a number of steps that you have to do to be able to talk just to a file system. So that's more downside, really. We have no generic interface. All the methods are different. We have all different APIs. As I said, with FTP, they don't support strings. So you have to know about the file system a little more in order to be able to talk to it. And we only looked at the calling part, but we haven't looked at the result even. But if you look at the result, it's different for every operation. So basically, you can't easily switch from one to other, because your entire application might rely on a certain type of response from the API that you're using, and another API might have a totally different response. So yeah, that's annoying. So more downsides. If you're choosing a file system and you're developing your application and you're just using it for a file system, then choosing a file system by definition creates technical debt if you have that in your application. If your classes are aware of a service like Dropbox being used, and you want to switch to S3 for your file system, or switch from S3 to Rackspace, for example, then you need to rewrite all the classes because they're all aware. So that's a lot of technical debt. And you don't want to create vendor lock-in for your application, because later on, if Rackspace turns out to be not ideal and you want to switch to AWS, you don't want to have to spend like hundreds of hours to rewrite all the things that talk to the file system. Sometimes that can be a blocking thing, and it will limit your choice in what file system you use. And it also requires you to invest. Like the first time that I looked at the AWS SDK, that thing is huge. So I really needed to dig in and see how I needed to use it, especially because all you have is arrays. It's not really easy to like work in your IDE and get code completion and know what you're going to say to the instance. So yeah, that's a problem. So now the complaining is really over. I'm going to be a little bit more positive now. So we know what file systems are. We know how to use them. We know when and why we would switch from local file systems to remote file systems. And now we're going to look at how file system abstraction helps you along the way. So the solution, of course, is using file system abstraction. So a file system abstraction, on the other end, is logic and structure that enable a generalized API to work with different file systems. So what does a file system abstraction do? In theory, it's just the adapter pattern. It will convert the messages you send to an object, like you call functions, and will convert that to the messages the adapter understands. And when it gets back a response, it will try to normalize that in the best way possible and give you that response. So the responses and the messaging is all identical to each other. So wouldn't it be great if there was something that could do this? And this is totally not shameless self-promotion, but I've been working on a package for the last year or so, which is a Flysystem. It's a file system abstraction package. And if you look at file system abstraction packages, it's an abstraction layer, of course, but it's like a database abstraction layer. More people are used to that. Probably everybody here uses that. But this is like a deval for your files. So it's well tested, it's well documented. The positive things about having the generic API is everything becomes easy and predictable. Also, you can use more in-depth knowledge about the different things and on a global scale. So one of these things is cacheable metadata. If you talk to remote servers, you're basically going over HTTP. You're going to talk to a file system, and that's a lot of overhead. So if you can somehow limit that amount of time that's spent on I/O, your application will be a lot faster. And a lot of times this has to do with inspection of stuff. So we want to know what's in a file system. We want to list directories, or we want to get a modified time. If we can cache that somehow, then that will speed up your application significantly, whether it's just at one request or consecutive requests, so in a persistent caching. So if you look at Flysystem, it's pretty easy. We instantiate it like this. We use the local adapter. We say at what root the adapter resides, so what his base path is. And then from there, you can do basic file system operations. So we write and we read, we update, we list contents and we delete, and it's a pretty simple API. But then, what if we need to move through S3? Well, everything stays pretty much the same. We just use the AWS S3 adapter now, and all the operations stay the same. So that's pretty cool. And if we look at FTP, I don't know who's here ever worked with FTP. I hope nobody, but if you do, I feel sorry. It's a hassle, and especially in cases where that is really important. It's FTP in PHP is easy to get wrong, because while FTP stands for File Transfer Protocol, it's more like file transfer, I will do whatever, because none of the responses seem to align really nicely, so it's not really following the protocol anyway. So that's a pain. And if we want to use streams, we just say, I want to read a stream, and then I want to write that stream. And in this example, you can already see I'm reading a stream from Dropbox, and I'm writing to to S3. And if you look at the amount of code that you need to produce in order to do this without a file system abstraction, I think it's like 10 or 20 times the amount of code that you see here. So yeah, it's a pretty big win in terms of how much you have to code. So basically, it's one API to rule them all. So how does Flysystem do this? Well, there are several parts in this process how it's able to achieve it. For starters, all paths are relative. There are no absolute paths in Flysystem. It uses the adapter pattern, as I said before. It uses a response mapping for everything it gets back. So everything will be on the same key in the response, and it doesn't matter anymore if the adapter would normally put that in a different key. Like, instead of contents, it might have body as the place where the file contents is stored. So you don't have to deal with that anymore. It also uses polyfilling in order to fill the gaps where support is not there. We saw the example before where we used streams, where we wanted to use a string and use F2P as a file system. We first needed to convert that. Flysystem has polyfills, so you don't have to worry about those things anymore. And it also eliminates a big set of common gotchas that you have to really know about about the file systems. For instance, if you want to write to S3 and you have really large files, you can do the normal uploads, but it might be super slow. But the SDK also provides a way to do concurrent multi-threaded uploads, but you don't want to have to figure that out all the time. And what Flysystem does on the fly is figure that out for you and then converts to which kind of upload is more applicable to your situation. So again, it's one less decision point to make for you. I talked about the file paths are all relative. I've had a number of questions like, why are all the paths relative? I want an absolute path right now. But if you look at paths as a whole, there are some things that your application or more like your domain layer or your service layer doesn't have to be aware of. And so it's a difference between what's configuration or what's an implementation detail and what's really the meat of your application. So in your application, you only care about the relative paths. So you say the root is somewhere here, and then if I want to upload a user file, like a user profile picture, I can just say user profile / and then images, and then upload it there. But then later on, if I want to switch to a whole different file system, because the root of the file system is not in the file system, everything is relative, it's super easy to port. And it doesn't matter where on the new file system the root starts. So it's super portable. That's, again, a huge, huge win. Also, I don't know how many here have tried to test file system interactions. Do you test your file system interactions? No testing of file interactions? Wow. Okay, I can sort of like understand that because it's quite difficult to test, and the only suitable way is to namespace your tests and then redeclare that function that you want to use in that namespace if you use the built-in PHP functions. And then you have to mock every kind of response that you want to get back from the file system, which is super annoying. So you don't want to be forced to do that. So when you're using Flysystem or any other file system abstraction really, this becomes more easy, a lot more easy. Like if we look at a class that would use Flysystem, we accept the file system interface, so we get a file system instance there. And when we get to bio, want to get to bio, we just say get bio location and read that location. And the tests for that are really super simple. Probably everybody knows mocking, so you mock the file system interface. It says you should receive a read with a particular path and return a particular response. As an added bonus, that really makes your test run a lot quicker. If your tests are hitting the disk every time you perform the test, it will slow down enormously. And not only that, but you also have to replicate all the different scenarios in your test bootstrapping, and that's really difficult to do, and it's a lot of hassle to work around if you just want to do some simple tests. So Flysystem does this for you. It will tackle all that hassle. And so if you're testing yourself using Filesystem interactions, then using an abstraction like this really, really eases your development workflow. It also improves the stability of your dependent code. If your code is aware of what file system it uses, and you want to switch something, you're breaking the solid principle. So a class should only have one reason to change, and changing the file system is not one of them. So your code shouldn't care about where it's stored, it should only care about that it's stored. Whatever is at the back, you shouldn't have to care about this. So Flysystem enables classes to be unaware of this, and that's really positive. As I said before, it opens up new possibilities, like the case where the video upload is now done by Dropbox instead of you. That's nice. And you can also use this in your development cycle to defer a decision. You don't want to have to pick a file system implementation at the start of your project. You can just start using the file system as you normally would, and then later, when it's more applicable to switch to something else, you can just chuck in another adapter and everything will be the same. Your application code doesn't need to change. And it's also nice to build packages on. So of course there's a Symfony bundle. The one-up guys, they build a bundle for it. In Laravel 4 there's integration. Laravel 5 will ship with Flysystem by default, so everything file system related will be done by Flysystem there. There's a backup manager, which does database backups, and it has to talk to file systems. But in that package, why would you want to do that all over again if not the core of your package? So you can depend on Flysystem to do that for you. And there are other, I think there's also a Zend integration, Zend 2, so pretty much for every major framework you can use. There are also some weird file system adapters that people have in the community have been creating. I think probably the most weird one is Reddit. So you can write to Reddit using the file system implementation. I don't know if you could ever do that, but yeah, you can. So there's that. Flysystem itself is part of the PHP League. Well, the official name is the League of Extraordinary Packages, which might sound like we're this kind of elitist group, but it's more like we needed a name, and we were joking around about it, and this is actually a better name than the original name, because we were first called the Super Best Friends Club. So, yeah, that's pretty silly. So I think we're good for now. I might change it later, not at all. What we do as a group is we tackle niche things. So most of the things in PHP land are framework related. Like you've got all the Symfony packages, you've got all the Laravel packages, Zend packages. But there's an entire domain out there, all like with super small things that need to be fixed that are not framework related. But there's not really an organization or a group that takes care of that. So the PHP League, we combine our packages into one vendor, which allows us to bring support as a group to all the packages. So you have the same stability factor as you would have with, say, a company backing a project. So it's not a one-man show anymore. All the packages are taken care of by a group. So that's, I think that's nice. So thanks for listening. Find me on Twitter. If there are any questions. So the question was if you can use this to talk to Mongo, and then probably you're referring to the grid file system in there. There is actually a pull request in the works for this to be enabled, and it is very much possible. So probably in the next release, it will ship also with Mongo support. Yeah, go first.
Okay, hi, thanks for this talk. You probably have heard about the Filesystem file system.
Correct. Yeah.
It's been here quite long. So what was your motivation to start building a new one?
I looked at GoFred before starting to work on this package, but I've had some, the way it works internally, I didn't really like that because, for example, I talked about normalized responses. I started using GoFred in local, and then after a while I thought, okay, I want to switch now, and I switched to S3, and my entire application broke because it had too much knowledge of what the backend was supplying. I haven't really dug into that a lot, but stream support is different. If a backend doesn't support streams, they will just throw an exception, and that will force you to create a string yourself. I use the polyfills for that, so it's more about the whole being portable. They have a generic API to talk, but in some ways you can still be locked into the file system. So that's what motivated me to create this. Sorry?
What about Symfony Filesystem?
Oh yeah, he said, what about the Symfony file system component? The Symfony file system component, correct me if I'm wrong, but that's only for local files. So if you use that, you could theoretically create an adapter which would talk from Flysystem to the Symfony component and just bridge that gap. But the same with other things, like you don't want to create that vendor lock-in or limit yourself later on when developing the application. If your application is aware of the Symfony file system component, then when you need to change to something else, you still have to rewrite all that code. So it doesn't allow you to defer the decision of where you store your files. So that's the reason not to do that.
Is it possible to access an existing file system, file system, say, I have to have so then I use slices to the existing files, or does it store extra information from
So the question was if you can use Flysystem for existing file systems. You can, because caching is a declaration around the file system interaction. So if it doesn't know anything yet, it will just ask, and it will hit the file system directly, but from there on out, it will have the cached data. So it will build its own cache as your application is used. So there's no worries there. It also doesn't create like inode files or nothing like that. No. I saw one question over there. Oh. The speed penalties, almost nothing. If you're talking to file systems, running a couple of functions more in PHP is like maybe 0.1% of the time if you compare it to talking to a file system. So Flysystem, because it caches certain things, will speed it up. So there's no penalty, there's only gain. So, yeah.
Again, how is the caching done?
How is the caching done? Okay, the caching is done per instance of a file system instance. So you create a file system instance, it has its own caching. And so one of the best practices when using abstract file systems is use one per domain. So it will cache the entire thing so it can reason about the entire structure that it talks to. But there are different kinds of caching that you can use. And because the caching is also an adapter pattern, you can also use different, you would be able to use different kinds of ways to store that. So you can, I don't use that myself, but you can do a one cache entry per file or one per directory. But by default, it will just cache the entire thing as a whole. Because if you list a directory, and you list it recursively, and then you would want to check if a file exists. If you know there's a full listing, you don't have to check for that because you have a full listing and the file isn't in the cache. So then you know more about the file system already. So.
You see, there is a Flysystem with Google Drive.
Google Drive. The question was, can you integrate Flysystem with Google Drive? It's funny, but Google Drive is not a file system. Google Drive is a document store. So in Google Drive, if you would want to create that, and a couple of people have tried it, the same for Windows Azure, but they've all hit the point that they can't reason about it as a file system. So in Google Drive, you would be forced to create things like inodes in order to speed things up, because you don't want to have an entire listing of all things, because it's ID based, you can't address it, and you need another persistent store in order to reference the IDs to the different file systems, which also makes it somewhat impossible to work with the same file system from different applications. Like if you want to use the same file system from a process that you have on the CLI that's written in a different language, so it doesn't use Flysystem, you corrupt the cache that way. So it's quite a difficult task to do. Yeah, so it is possible, but it's not easy. That's it? Yeah. Okay. Well, thanks for your time.